continue with this load word instruction I have here. Load word, A0, 16 for the offset, S4. Just a quick review, what this means is there is an address, hopefully, stored in S4, this register. From that memory address, move 16 bytes away. So that's probably index of 4 in an array. I say probably, that's normally what you're doing when you use this. Get that data out of memory, load it into register A0. What for? So it can be used in an add operation, sub operation, something like that. So we'll go ahead and get started here. I think you should remember that this is an I format instruction. So an I format instruction is expecting an opcode of 6 bits, an RS, which will be the source where the address is, an RT, in this case that's the destination where the data will be loaded, and then an immediate, which is the offset, okay, of how many bytes we need to move away. So in this case, I look up load word on my green card and I find the exact match for its opcode. I see it in both decimal and binary. I believe it's also there in hex. I'm just going to write the decimal now, just to save a little space. But normally I just go ahead and write the binary code right off the bat. RS, the source, is actually the S4 register. You may recall from previous examples that the S4 register is register number 20. If you're not sure of that, it's on the green card. All the registers are numbered from 0 to 31, and you can find those on your green card. RT then, in this case our destination, that's the A0 register. The A0 register happens to be register number 4. The immediate, right here, that's my offset in this case, is just the number 16. Now I can start to put this into binary. You could either take the time to rewrite the number 35 in binary, or you can just copy it right off your green card because it's already there. And I believe in binary, 35. 35 happens to be 1, 0, 0, 0 again, 1, 1. It should be 6 bits, so you might want to just double check, make sure you're transcribed. Then I need to take the number 20, write it as a 5-bit binary number. That happens to be 1, 0, 1, 0, 0. Then I need to write the RT register, register number 4, as a 5-bit binary. 0, 0, 1, 0, 0. And then the number 16 as a 16-bit binary number. So that'll require a bunch of zeros in the beginning, so I just kind of write them like that to save space. Then 0, 0, 0, 1, 0, 0, 0, 0. And there I have my 32-bit encoded MIPS instruction. To change this into hex, let me get another color. I divide this into 4-bit chunks, remember? 1, 2, 3, 4. 1, 2, 3, 4. Here's 4 here. There's going to be a couple of them here. Oops, and there's another 4 there. Now, for each chunk, I simply turn this into a hex digit. This one happens to be the number 8. This one happens to be the decimal number 14. When I change that into hex, because remember we don't want to represent 2 digits, we want to represent with only 1. Turns out to be the hex number or digit, if you will, 8. Again, if you're not sure on this, you want to check out a quick tutorial on hexadecimal numbers. This happens to be the number 8 again. 4, 2 zeros, a 1, that's 0, 0, 0, 1, and a 0. And this is the hexadecimal encoding of this instruction.